In vitro digestion studies are applied to mimic the in vivo physiological conditions of the digestion process by taking into account digestive enzymes, pH, digestion time, and salt concentration of the digestive fluids. Choice of controlled and reproducible conditions and easy sampling at the site of interest make in vitro models very suitable for addressing the study of food digestion. In the Food D Health Lab at the Polytechnic University of Valencia, we have adapted the international protocol for in vitro digestion studies by the InfoGest group in order to accomplish the ultimate goal of my CFAP project: develop an evidence-based method to adjust pancreatic enzyme replacement therapy in cystic fibrosis. To achieve it, we simulate digestion of foods with different doses of the enzymatic supplement, which is the responsible of lipolysis, and different gastrointestinal conditions such as pH or bile salts concentration. In the following explanation, we show the live application of the protocol from the sample preparation and including the step-by-step specifications of the process. The first step of the in vitro digestion is the oral stage. Mastication is simulated with a mortar in order to obtain a particle size similar to the size resulting after a real mastication. 5 grams of the homogenized food sample are weighted into each of the 10 tubes that will be submitted to digestion simultaneously. Then 5 milliliters of the simulated salivary fluid based on stock solution and alpha amylase are added to the tubes in the proportion 1:1. The oral stage is finished after manual agitation is applied to mix the salivary fluid with the chewed food sample. The gastric stage starts with the addition of 10 milliliters of the simulated gastric fluid containing pepsin. This addition allows the sample to reach a pH equal to 3. The volumetric 1:1 proportion is then maintained. If needed, hydrochloric acid or sodium hydroxide can be added to exactly adjust pH to 3. Then the digestion tubes are placed in the head over heels stirrer, which simulates the agitation produced by the stomach walls during gastric digestion. This stage takes place in the interior of a thermostated chamber that maintains the process at a physiological temperature of 37 degrees. This stage has a duration of 2 hours. Every 30 minutes, the tubes are taken out from the chamber in order to check pH changes caused by the process of digestion. Hydrochloric acid or sodium hydroxide can be used to readjust the pH value to 3. After 2 hours of gastric digestion, the intestinal stage is started by the addition of the simulated intestinal fluid, which contains mainly sodium bicarbonate and biliary salts. The concentration of the bile salts will depend on the objective of the experiment. In order to maintain the 1:1 proportion, 20 milliliters of this fluid is added to the product of gastric digestion. The addition of this fluid allows for a pH increase to the physiological value of 6 or 7, depending on the objective of the experiment. The pH meter is used again to adjust the pH value with the use of hydrochloric acid or sodium hydroxide. At this point, the pancreatic enzymes are added, which have been previously dissolved in the necessary volume to reach the target enzyme concentration in the digestion medium. Then, the digestion tubes are placed again in the head-over-heels stirrer in the interior of the thermostated chamber at 37 degrees. As in the gastric stage, the pH must be readjusted every 30 minutes in order to compensate for the acidification of the medium, as free fatty acids are released as the product of lipolysis. Lipases are very sensitive to the pH, thus maintaining it constant along all the process is of major importance. After 2 hours, digestion tubes are taken from the thermostated chamber and quickly introduced into an ice bath for 10 minutes, which will inactivate the enzymatic activity. Then samples are adjusted to pH higher than 9 in order to further guarantee enzyme inactivation. This represents the end of the intestinal stage, therefore the end of the in vitro digestion process. First, digested samples are centrifugated to separate the solid and the micellar phases. The solid phase represents the undigested parts of the food, while in the micellar phase the products of digestion can be found. The centrifugation conditions are set at 4,000 revolutions per minute during 20 minutes at room temperature. After centrifugation, a sieve is used to separate the two phases. The solid undigested phase remains on the sieve, while the micellar phase, containing the free fatty acid products of digestion, is collected in a vessel. From the filtered micellar phase, aliquots are taken into lyophilization vessels. Complementarily, aliquots are taken to be frozen for possible future experiments. Then, aliquots for lyophilization are brought to freezing temperature. After overnight, frozen aliquots are brought to the lyophilizer. This process will remove the water of the sample, leaving the digested parts ready for further analytical determinations, such as measurement of free fatty acids as a means of quantification of lipolysis.